You have to simplify the algebra first of all, using your laws of indices, and then differentiate. So at the beginning of a question, it may say, show that this is equal to an expression, and then differentiate. So again, look at our standard results that we used before. So it's multiply by the power, divide through by the, multiply by the power, subtract 1 from the power. I'll just give you a bit of integration there. Right, on this first one, we can't do anything as it stands because we've got a square root sign there. So we've got to unravel it and put it into the form, shall we call it y this time? So y is equal to 1 over 4 root x. Now that's why yesterday I concentrated on so much you've been able to unravel it. So it stays as a quarter, and then the power becomes x to the minus a half. If you don't get that, can you ask me why? Okay, everybody's all right with that, yeah? We're now in a position where we can do our dy by dx again. So multiply by the power and subtract 1 from the power. So it starts to get very tricky with all the fractions and negative numbers that we've got. So that becomes minus an eighth and x to the minus 3 over 2. And then if we want to put it back into the form that we were given originally, it would be minus 1 over 8 x to the 3 over 2, which is minus 1 over 8 root x cubed. So again, there's your three different forms. Your negative power, make your negative power positive, then put it into roots and power form. But part B is a little bit tricky because we've been given an algebraic expression and we need to be able to simplify that so that we can then differentiate. So we'll multiply the brackets out, so it's both there, and we get y is equal to 3x to the 4 plus x cubed. Apply differentiation, multiply by the power, take 1 away from the power, and then that's fairly straightforward, yeah? On part C, we've got x minus 2 all over x squared. So we've got to put it in a form that we can deal with powers. So we can split it up because it's the top line just being divided by x squared. So if we do that, we get x to the minus 1 minus 2x to the minus 2. Can you please make sure I haven't made any mistake? If I put a 1 there, you can see it's just 1 minus 2, isn't it? But carrying out differentiation then, multiply by the power, take 1 away. So if we simplify that, because we don't need the 1 in front of it. Now I'm going to shift around. I'm going to put the positive 1 first, and then the negative 1 second, because it does make it a little bit neater rather than having a minus sign hanging about. And then we'll put it into the form that we would use for substitution. So we've got x cubed. Has any of you got any questions? It's okay? Yeah? Okay, a few more for you to do then. Okay? What I suggest we do is probably all of them, because I've only got 2 questions there. That's all I've chosen for you. So 2 questions, can you crack on with them? You can either make y equal the function or f of x equal the function, and then do it from there. So if we give you about 5 minutes or so for question 1, then we'll stop, have a look at the answers and then do the same for question 2, okay? Can we check up to F, see if you've got as far as there, or the first few anyway? Right, for the first one, straightforward. You should know that the root is to the power of a half. So multiply by the power, so 2 times a half is just 1, so that's why it looks as though it's disappeared. And then we put it back into the form that we had at the beginning, or the substitution form. On part B, multiply by the power gives you the -6, then subtract 1 from the power, then make this into a positive power so it goes on the bottom. -3 times a third is -1, subtract 1 from the power, and then make the power positive. Everybody happy with that? It's the straightforward ones at the beginning. We now have to expand and simplify. So we have a third x to the 4 minus 2/3 x cubed. Multiply by the power, take 1 away from the power. That one's actually fairly straightforward. The fractions on that are okay. The next one, not so nice. I think I've made a mistake as well. No, I haven't. I thought I had, but I've not. Watch out for signs. So we multiply by the power, take 1 away, so that's straightforward. Multiply by a half and take 1 away from the power gives us -1/2. So this comes to the bottom, x to the 4, and then I've just said x to the half, which is root x. Now watch out in particular, you've got plus a half x to the -1. When I multiply a plus with a minus, I get a minus. Yeah? Also watch out if you've got a minus power and a minus number in front of your x, because you're going to get a plus there. And I can guarantee that you'll slip up and make daft mistakes like that. So signs, check signs. We have multiply by the power, take one away. So a third minus 1 is minus 2/3, so you've got to be doing these fractions in your head. Minus 1 times a half is minus a half, and then take 1 away, and then I've done the rest of it up till there. You happy with that? It's a lot, isn't it? A lot of fraction work, a lot of negative numbers, and then your laws of indices are coming in with that as well, so we're pulling all the things in together. How are you feeling about them, okay? Should we crack on? Keep going? Right, another 5 minutes then. Watch your signs. check. We'll do L together. It's quite a tricky one because you've got a full 2 brackets to multiply out. Now the one that stands out here is I. That there would be a typical exam question. So expect to be able to know that root x is x to the half, split it up into your fractions, use your laws of indices, and then carry out the differentiation. So that's the main type that you would get in an exam. Right, have a check at your answers and make sure that you haven't made any daft mistakes. I think the other thing to watch out for is on H, where we have a negative power, so -1 times that negative there gives you a plus. Watch out for your signs. And then we'll do L together. So it's a case of multiplying everything out very carefully and then applying differentiation. Right, let's do L then. So if we do the first part, it'll just be 3x times 4x would give us 12x squared. If we then do -2 times 4 gives me -8x. I'll then do the 3x times the 1 over x, which will just give me 3. If you think about it, 3x is over 1 multiplied by 1 over x. They simply cancel, so you're left with 3. And then your last one is 2, so it'll give you -2. I'm going to make it as x to the -1. Happy with that? See what's going on? If you multiply in a different order, that's fine, as long as you check that you've got the same terms in there, that's okay. So divide by dx, multiply by the power, take 1 away. Same with that one. 3 is a constant. So when you differentiate a constant, it goes to 0. Now, -1 times -2 gives me +2, and then take 1 away. And then pop it into the form again that you would use for substitution. It will be 2 over the x squared. Is that okay? Right, question 2 is actually asking us to find the gradient of the curve at the point A, and A is given in each part of the question. So can we do question 2 together? So let me do that. Question 2. The first one's giving us f of x is equal to x plus 1. And A is the point 0, 0. So the first thing that we have to do is multiply it out, gives us x squared plus x, then differentiate it, which gives us 2x plus 1, and then we want the gradient when x is equal to 0, so f dash of 0 is 2 times 0 plus 1, which is simply a gradient of 1. And same sort of things for the others. For part B, we've got f of x is 2x minus 6 all over x squared. And A this time is the point 3, 0. So we'll simplify the function first of all. And the f of x is equal to, well, that's going to be 2x to the -1. And 6x to -2. We'll differentiate. And we'll put it in a form that we can use for substitution. And then we'll find out, because we want x is equal to 3, we'll find f dash of 3. That's -2 over 3 squared plus 12 over 3 cubed. And 12 over 27. Right, lowest common multiple, would that be 54? No, 27. So they both go into 27, don't they? So again, no calculator, not very nice. So if we make that 27, multiply the top by 3, and we're going to get 6 over 27. Simplify as much as possible. We can divide the top by 3 and the bottom by 3, so it gives us 2/9. How many marks do you think that would be worth? What do you think? 3? Anybody more than 3? I would go for, let's have a look at method marks and things. So we get a method mark for that, probably 2 accuracy marks for that, a method mark for actually doing the differentiation, and an accuracy mark. And then the final would be an that. So I would probably say 2, 3, 4, 5, 6 marks for that. 5 or 6 marks. So there's quite a lot to it, isn't it? It's quite synoptic towards the end. Right, looking at part C then. Let's move on to the next question 2, part C. This time we've got f of x is equal to 1 over root x. So we've got to change that to x to the minus a half. And this time we're told that a is a quarter and 2. So f dash of x is going to be equal to minus a half x minus 3 over 2. Let's put it in a form that we can actually do substitution. So 1 over 2 x to the 3 over 2, which is 1 over 2 root x cubed. And we know that x is equal to a quarter, so we want f dash of quarter. Right, would you like to do some substitution there? Remembering that when you take the square root of a number, you could actually get the plus and minus values. That's my warning. So we're going to get 2 values here.